All right, hi everybody, it's Dr. Dan, and today we're going to do tension testing of the chicken tendons that we dissected. In order to do this, the first thing we have to do is do some prep work. We want to measure how big it is, right, because we need the cross-sectional area so we can compute stress from force. And I'm also going to do something a little different than I have in the protocol, is to make it easier on the grips, I'm going to go ahead and super glue some wood blocks on the ends of the tendons. Normally I don't have students do this during the semester because it just takes a while and I just fear it's going to be messy with super glue everywhere. And so the grips we have are actually pretty good at holding in the tendons because they're pneumatically controlled and they really hold in the tendons well. But this is probably this is what I used when I test heart valve tissue when I was a PhD student. And this is probably more useful just for you guys to see that, hey, if we can glue these wood blocks on, it makes it a lot easier to hold tendon tissue, or any tissue for that matter. All right, so what I have is basically some little wood blocks. It came in a strip of basswood from a hobby shop for like $1 for this long strip, and I just cut them with a X-Acto knife and to make some wood blocks. So let's go ahead and I'll show you exactly how I would do this. You get a tendon out. Okay, and so these tendons were in the freezer in the combination of glycerol and PBS. And so I went ahead and warmed them up in the water bath to get them closer to their normal temperature. Okay, so they are ready to go. Well, let's go ahead and I'm going to get a block of wood here, and basically all I'm going to do is put a dab of super glue on the block of wood. Then I'm going to stick the tendon onto it, glue it down, and I'll glue another block of wood on top of that. Super glue works really good for this because that's what it was originally designed for, is for gluing tissue. It even wants to stick to my tweezers there. And so the trick is not getting it on your tweezers. Okay, so that's one side, and now the other side is very similar. So a little dab's all I need. Of course, the trick here is making sure this is lined up pretty straight, not twisted at all. And it is not exactly easy to do that well. And I just want the front and back side pieces of wood so that they make that parallel, nice shape that we can test. Okay, now we should be able to grip that in the tension tester. And so what I can also do is label these. This makes it easy to label the tissue, so I can get all my samples ready and I can label them all. So I'll just use like a marker. I'm going to put like a single dot there, right? And so then I can like start incrementing the number of dots or whatever, or make X's or whatever symbols. I mean, it's kind of hard to write 1, 2, 3, 4, 5, so I usually just do like a dot. And then we can actually store this in PBS. So I'm going to get a little PBS in this one. And what we don't want to happen is for this tendon to dry out, because that will definitely change the mechanics of it quite a bit. And the good thing about super glue and the wood is it's pretty much all water resistant. And so we can just put all our tendons in the PBS while we're waiting. Okay, and so I will go ahead and repeat these. I'm not going to show you a video of repeating all these things because that would be pretty monotonous. But I do want to show you, we also need to measure it, right? Like I said, we need to measure cross-sectional area. So there's a couple ways to do it. Number one is just trying to use calipers. And you can see even in this picture, in this piece, the cross-sectional area is changing. And so that makes it a little bit difficult, but we could use calipers to measure that distance there. The problem with calipers is we can kind of squish it to make it whatever we want. And then we could also measure the other side by just turning this on its side. And we could treat it, these tendons, as basically rectangles. They're not quite rectangles, but they're pretty close to like ribbon-like, right? And so then I could measure the thickness of the tendon this way and get a measurement. Again, you could squish the tendon and get whatever measurement you might like. So the other thing I like to do on these, and it's especially easy to do it all at once, is if I go ahead, and I'll try to show you over here on this piece of paper, if I set my tendon down, and I go ahead and set my calipers to just any known measurement, all right? So this is 4.29 millimeters. And I put it next to the tendon, and I try to get it in about the same focal plane. So that's what takes a little bit of work, is making sure the tendon and the calipers in the same focal plane, right? I could take a picture of that, and then I analyze the picture, and that will, then my scale will be the distance between the two caliper pieces, and then I could use that to measure my tendon. Okay, I think that's probably the most accurate way to do this with calipers, and so that's what I'm going to do here. Again, this is not something I'm going to show you every case of, but it's something that I will do as I'm prepping all my samples.